Welcome back to Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to discuss the mammalian metabolism and processing of one of the B vitamins, that is vitamin B6, also called pyridoxine. Now, the chemical structure of pyridoxine is shown over here on the top right, and this is actually one form of this B vitamin, vitamin B6. There's actually two other forms that we can actually intake through the diet. One of them shown over here in the middle, this is pyridoxal. Notice the aldehyde present at the top, the oxidized version of this alcohol in pyridoxine. And then also we can get pyridoxamine, which instead has an amine up here on top of the ring. All three of these forms are going to be necessary to get through the diet because humans lack the ability to biosynthesize any of these three precursors. Well, why are they precursors? Because neither of these three B vitamins are actually going to be the active form of vitamin B6. The active form is actually going to be this form down here circled in purple, pyridoxal 5' phosphate, also just called pyridoxal phosphate, or PLP, which you'll often see written below reaction arrows to denote that an enzyme is PLP dependent. Okay? Now, pyridoxal phosphate can be generated from any of these three precursors, and so now we're going to look at the biosynthetic pathway, which is actually more of a salvage pathway. So here we have pyridoxine. How do we get that and convert it into PLP? Pyridoxine is going to react with an enzyme called pyridoxal kinase. Pyridoxal kinase is going to phosphorylate this hydroxyl group over here on the right side of the molecule using the phosphate from ATP. As you can see right here, that's going to generate this molecule called pyridoxine 5' phosphate. This molecule requires an aldehyde up here at the top rather than a hydroxyl group. So we have to react it with pyridoxine oxidase. This is going to convert pyridoxine 5' phosphate into pyridoxal phosphate. Notice the alcohol is oxidized into an aldehyde up here at the top, and it uses the oxidizing power of molecular oxygen. In the process, we get out a hydrogen peroxide, which will be dealt with further via catalase. Also, one thing to denote about pyridoxal phosphate, this Al in the naming of pyridoxal is to denote that the active form must have this aldehyde up here at the top, because al is the suffix for aldehydes. All right, over here on the left we have pyridoxamine. This is going to follow a somewhat similar pathway than what we saw for pyridoxine. Pyridoxamine can be obtained through the diet and also reacted with pyridoxal kinase. Again, it's going to use the phosphate from this ATP molecule to phosphorylate the hydroxyl group over here on the right side of the molecule. That's going to generate pyridoxamine 5' phosphate. And again, as in the case over here on the right, pyridoxamine 5' phosphate is going to be oxidized up here at the top by pyridoxine oxidase. This enzyme again uses the oxidizing power of molecular oxygen to oxidize this amine ultimately into an aldehyde as shown right here. Okay, so again, the same reaction, a slightly different mechanism, but you're going to get the same product, pyridoxal phosphate. All right, now we can also directly have pyridoxal. So pyridoxal is going to be a simple conversion to pyridoxal phosphate. All we need is this pyridoxal kinase. It's going to again phosphorylate this hydroxyl group over here on the right. And notice that's the only difference between pyridoxal and its phosphorylated form. So we just need one kinase reaction and we've now got pyridoxal 5' phosphate. This again is the active form of the cofactor or coenzyme vitamin B6, and the way we get it to be fully active is we have to ligate it to what's called a PLP-dependent enzyme. There are many PLP-dependent enzymes, and essentially what they do is they use a lysine residue somewhere on their structure, and the lysine will actually attack this carbon of the aldehyde up here, and it will actually form a Schiff-base linkage with this entire ring via this carbon where my mouse is, and it ultimately connects through a lysine residue. Once this moiety is attached to the enzyme, it can then perform whatever PLP-dependent reaction mechanism is required. And we'll have a separate video where we actually look at the attachment of it and then also potential detachment from the enzyme. Okay? Now in any case, if we have a pyridoxal 5' phosphate and we don't need any more of it, we can actually convert it back to pyridoxal, and if necessary, this can be removed from the body. The removal of this phosphate is catalyzed by pyridoxal phosphate phosphatase, as you might guess. It uses the hydrolytic power of water to hydrolyze off this phosphate, and we get off inorganic phosphate, and notice that pyridoxal now is back to having this hydroxyl group right here. Okay? But in any case, the pyridoxal phosphate, this is the active form of vitamin B6. And so any of these three precursors have to be obtained through the diet, but then are going to have to be processed further either by 1 step or 2 steps into PLP. And then this can be ligated to particular enzymes, and once it's ligated via the lysine residue to this carbon up here atop the ring on the aldehyde, then it can perform the reaction mechanism. So hopefully this video made sense to you. Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you very much, and join us in the next video.